Did it start? Okay, great. Okay, so it's the numerical measure for how strong the correlation is. The correlation is, okay, okay. So we have this scale here, okay? 0 is going to be in the middle. The -1 is on the one end, okay? This is the lowest value it can take. And the highest value it can take is 1. It's always going to be between -1 and 1. Now, if you have a value that's close to -1, this means that you're going to have a strong correlation, okay? If you have it exactly at 1, it's going to be perfect. And a -1 means you're going to have a negative correlation. So if you have like a perfect correlation, that means that you can draw a line directly through every single data point and it hits every single data point. Okay, that would be a perfect correlation. That would be if your R value was exactly -1. And the negative indicates that it's a negative correlation. Your line has a negative slope. Okay, and remember, this is linear regression, so we're sticking lines through things. Okay, we're not using curves. Now, and it could be a steeper slope than this, maybe, but the point is that it's a negative slope and it hits every single data point. Okay, but if it's maybe close to 1, like 0.9 or something like that, it's going to have a strong correlation, but maybe not every single data point is on that line. Okay, maybe you have a few straight ones. When you hit -1/2, you're going to have a moderate correlation, and anything between 1/2 and 0 is going to be pretty weak. Okay, 0 is like there's no correlation at all. So you have a line that you could try to draw maybe, but it doesn't, like, you don't know whether it would be positive or negative because the dots are just like all over every single one. So there's no correlation whatsoever. Okay. Same sort of thing goes for the positive side. Okay. So we'll put a 1/2 in the middle right here. All right. We have a weak correlation over here, a moderate around a 1/2, strong close to 1, and 1 is going to be a perfect correlation. And this time, since we're on the positive end of the scale, we're going to have positive slopes. So a perfect correlation is going to look something like this, where we have every single point exactly on the line. Okay, moderate, maybe we have a positive slope, but not every single value is going to cut that line. Okay, there's a few points, data points that are far away from the line of best fit. So what questions do you guys have about that? Anybody have anything? Okay, I'm going to assume that means no. So we can have, so when we have these correlations here, these linear correlations, we could do something called extrapolating, where we go beyond the given data set, and maybe this line goes up here, and we guess what a data point might be farther along. And so a good model to use for that is one that has a strong relationship. Okay, so that R value is going to be really close to positive or negative 1. Okay. Now, the extrapolation thing that I mentioned is not necessarily the best way to, or the strongest way to make a prediction. The strongest way to make a prediction is going to be something called interpolation. Okay. This is when we have given data points that we know. We had a pretty strong relationship, and maybe we want to guess a data point that's within the given data. Okay, so interpolation is when you guess something within given data. Okay, so do you see how, like, we have a data point down here, we have a data point past that pink point, and we just wanted to know something that was in the middle. So a good model to use is when we have a strong relationship and we have enough data so that the data point we're looking for can be interpolated. It can be within the given data. Bad models to use are going to be when we have a weak relationship. Okay, so our what's it called? Pearson's correlation coefficient, the R value is going to be closer to 0. And a weaker way to make a prediction is to extrapolate. Okay. The word extra is going to mean like beyond or outside. So maybe we have our data points here, and maybe we do have a strong set of data points, but they're within this section, and we want to find a point way out here. This extrapolation is going to give us something that's not as good of a prediction. So extrapolate means outside given data. Okay, what questions do you guys have about those two types of models, good models, bad models, and characteristics of them? Any questions? Anything? Can somebody say something? Like, we have no questions.
Something.
Good.
Okay.
Very funny.
Huh?
I said very funny.
Oh, okay. Well, I guess if there are no questions and you guys understand that perfectly, we will move on to using your calculator. So if you want to follow along and kind of do the keystrokes to enter data into your calculator, feel free. We are going to do examples later, so don't worry about it if you don't want to. But step 1 is going to be to enter your data. Okay. So in order to do that, you go to Stat, then Edit, and you're going to enter your X values into L1 and your Y values into L2. Okay. Technically, you could flip it around if you really wanted to, but this is just because you can specifically define what you want L1 and L2 to be in your calculator, but it's just easier to start with X and end with Y. The second thing that you will do, so I guess I'll show you. Also, mine is a TI-83. It's super old, and apparently you can't see it. So let me find my light and maybe, come on, turn on. Ugh, it doesn't want to work. Maybe I can change my, Hey, there we go. Okay, so it kind of washes out my paper, but you can see the calculator. So what you're going to do, turn it on, go to, where's stat, and it pops up with edit, click enter. You're going to enter your X values into L1. Ideally, they'd probably be in order, but they don't have to be. And then your Y values into L2. And then once you have your data set in there, you're going to run a regression on that data. Let me undo these ones. So run a regression is step 2. Okay, and you do this, I should have given myself more space, by clicking stat, calc, and then lin reg. Okay. You can store by doing, oh man, hold on. Not how it starts. Reg EQ. So you can like store this equation. So by doing vars, y vars, and then function y1. Okay. Once you've done that, step 3 is to make your scatter plot. Okay, so you do second stat plot, turn the plot on, oops. Okay, and then it's usually not going to be zoomed in properly, so you do zoom stat. And then it will zoom in to wherever your data points are in the scatter plot. And don't forget to check that your stat diagnostics are on. Okay, otherwise they might not show up. I remember there being an issue last year with the seniors where sometimes their regression stuff didn't show up. So with this fake data that I've put in, so I have my fake data here, right? Okay. So the next step was to actually run the regression. You do stat, calc, and then run down to lin reg. Okay, and when you click enter, oh, I'm sorry.
Oh, I was just gonna ask you to move the calculator off of the notes so I could finish writing.
I guess that's okay.
Oh,
Can you see it though?
Yeah. What does reg EQ mean?
So I think that that's where we like store our regression equation so that you can plot it on your scatter plot.
Okay. And does that say vars?
Yes.
Okay. Just making sure. Okay, I'm done.
Okay. Let me see where to get to the reg EQ thing. Is there a... Honestly, I don't remember using that part. We do vars. Oh, there it is. Vars, y vars, function, and then you pick y1. Oh, yeah. Okay, so what we would do, so we would do stat, calc, run down a lin reg, and then it gives us this linear regression. Okay, so
it's hard to see the calculator. Can you turn the regs back up so we can see the calculator?
I feel like you can see it. Okay, so A is your slope and B is your y-intercept, and it calculated the line of best fit through the data points that you have. And so